Okay, students, now that we've learned about the open system and we know the results from that, we're going to go on to part 2, and this is working with a closed system. And we'll use the same process, but we're going to use a closed system, which we'll show you in a minute. But I'm not sure where Mrs. Anderson is, so it's not like her to be late, as you guys already know.
Hi, Mrs. Benish. I'm sorry I'm late. Sorry.
Hi.
I had to run up to the cafeteria. I was so thirsty. I've been talking so much. I'm not used to it. So sorry, I just had to get something to drink.
Yeah. Okay.
What are we doing?
Well, did you drink all of that?
Yeah, I was really thirsty.
Okay, because, this is good timing because we're working with the closed system now.
Okay.
And with the closed system, we need that bottle.
Yeah, so this is a closed system because it has a cap on it that we can use to close it up.
Perfect.
And that's the difference between the open and the closed.
Oh, yeah. Perfect.
Okay, cool.
Okay, so let's get started. So everyone, look at your data table. The first thing that we're going to do is measure the mass of the other half of the Alka-Seltzer tablet, because we used half of it for the open system, you remember. Now we're going to use the other half and get the mass of that. Okay. And it should be pretty similar. So I bet you could predict, if you look back at your data table, about what the mass was. And that one was 1.9.
This one is 1.8 grams.
1.8. Okay, so let's record that. We're going to be right here on step 5 now, and that's going to be 1.8 grams. Okay? Next, we need to get the mass of the bottle and cap plus 10 milliliters of water. Now remember, Mrs. Anderson just finished her bottle of Gatorade or juice or whatever she had, and she's adding the water to it, and she's going to put the cap on too.
Got to have that cap.
So that's going to be our closed system. All right, and we'll get the mass of that. Now, plastic is a lot lighter than the glass beaker, so we're going to get a much smaller number with this one.
So we're in the 30s here.
Okay.
We're looking at about 36.4 grams.
Okay, so everyone, this is going to be number 6, all right, on your data table. Could you repeat that again?
Sure, 36.4 grams.
Okay, so 36.4 grams, everyone, for number 6. And now on number 7, calculate the mass of the bottle and cap plus the water plus the Alka-Seltzer. So just like we did up above, we're going to add numbers 5 and 6 together. All right, so that should give us 2 here, carry the 1, 38.2 grams. All right? All right, now, this is the fun part. Now, it says on number 8, the mass of the bottle and cap and water and Alka-Seltzer after the reaction has stopped. So we're going to, excuse me, we're going to do the same reaction with the Alka-Seltzer tablet and the water in the closed system. Okay, so Mrs. Anderson's going to drop in the tablet
and cover
put the cap
right
on.
away.
And right away,
cool.
We're going to see some bubbles forming.
It's doing its thing.
Now this time we can't hear it because it's in a closed system, but we can certainly see lots of bubbles forming.
That's right.
Now what we'll do is we'll wait for that reaction to be complete and no more bubbles of air or gas forming, and then we'll come back and measure the mass after the reaction. Go.
All right, everybody, it looks like the reaction has stopped inside the closed system. So if you take a look here, we'll check the mass. We are at 38.2 grams.
Ooh.
So please record that in spot number 8 down here. After the reaction, 38.2 grams.
That's interesting.
That is interesting.
Same as the mass before.
I wonder why that is.
Okay, everyone. Now we're going to use all this information that we learned from the open system and closed system to work through the summary questions on page 2. Thanks for listening.
Hey, Mrs. Von Eschen, one last thing. Let's just check and see if something kind of fun happened here.
Okay, let's check it out.
I'm going to come in close here. Listen close, everybody. Did you hear it? It made a little psh sound. So we definitely know there was some gas or air created in here.
Beautiful sound. All right. Bye, everybody.
Bye-bye.